Hello students, today we are going to discuss about AC generator. In the last video I told to produce the induced current, the better way or the best way is to rotate the coil in a magnetic field, and that is what we are doing in AC generator. AC generator is a device which is used to convert mechanical energy into electrical energy. So it is a device which converts mechanical energy to electrical energy. And let us see what is the principle of AC generator. Principle of AC generator is electromagnetic induction. When a closed coil is rotated in a uniform magnetic field, there will be a change in magnetic flux linked with the coil. And as a result of the change in magnetic flux, current will be induced in the coil. That is the principle of AC generator. Now, just see the figure. The figure consists of two magnets, north pole and south pole, and a rectangular coil PQRS is kept in a magnetic field. And there are two rings which is called slip rings, which are connected to two brushes B1 and B2. And through the brushes the current will come out through the load. Load means the resistance that we are connecting, the devices that we are connecting, that is called load. Now what will happen? How will it work? This rectangular coil PQRS is wound on an iron core. That iron core plus the rectangular coil together is called armature coil. This armature is rotated by mechanical means. Say for example, water flows from the dam, and that flowing water is used to rotate the turbine. The turbine is connected to the shaft of this armature. So as the turbine rotates, the armature will rotate. And what happens when the armature rotates? When the armature rotates, there is a change in the magnetic flux. And due to the change in the magnetic flux, current will be induced. And that current will flow through the coil. Okay. Now, let the armature be rotated in such a way that the arm PQ goes down and RS come up from the plane of the diagram. So, I already told the current formed will be alternating current. So, I want to say what is alternating current. The current which changes the direction periodically. The current which changes the direction periodically. And the magnitude of the current will change continuously. And such current is called alternating current. So, I have to explain what is how the direction of the current changes. So for that, let us see the working. The armature be rotated in such a way that the arm PQ goes down and RS moves up. The induced current is set up in the coil, and by Fleming's right hand rule, the direction of current is from PQRS R2 B2 B1 R1 P. I'll just tell you how it happens. Look at the first figure. As I told, PQ moves downward. So we use Fleming's right hand rule. The thumb moves downward and the magnetic field is from north to south. So look here, look at my fingers. The magnetic field is from north to south. So my point finger, that means this point finger is from north to south. And I told PQ is moving downward. So my thumb is into the screen in this direction. So in which direction my middle finger stays. The middle finger is from P to Q. Okay, so the current will flow from P to Q. Now look at the arm RS. In the RS, I told RS is moving upward. So magnetic field is north to south. That means my point finger is from north to south. And the RS, the component RS is moving outward. So I stretch the thumb outward. So think about my middle finger. My middle finger is like this. That means from R to S. So the current initially will flow from P to Q to R, S, B1, B2 and P. So this is the direction of the current flow. Now in the second figure, this coil turns, and after half rotation, S and R will come here, Q and P will come here. So the coil is rotating in the clockwise direction. So in the second half rotation, RS goes inward and PQ comes outward. So again I use Fleming's left hand rule like this. Like this, and RS moves inward. So you can see that the middle finger is upward. Similarly, QP is coming outward. So my thumb is in the outward direction and magnetic field is from north to south. My point finger shows that, and then look at my middle finger downwards. That means from Q to P. So in the second figure, you can see the current is flowing from S, R, Q, P, B1, B2, R2, R1, S. So initially the current was flowing from PQRS, and after half rotation the current is flowing from SRPQ. That means the direction of the current changes after every half cycle. That is why it is called AC generator, and that is why the current produced is called alternating current. Okay, I did this figure for explanation, proper explanation. You don't have to draw this figure in the exam. You can draw the figure from the textbook. Now look at this. Phi is equal to BA cos theta. If the loop is having n number of turns, then we can say phi is equal to NBA cos theta, and theta equal to omega t. We studied omega is equal to theta by t. So theta is equal to omega t. Omega is the angular frequency. So phi is equal to NBA cos omega t. Now we know d phi by dt is called induced current. So I am going to differentiate the above equation. Phi is equal to NBA cos omega t. So when I differentiate this, I will get d phi by dt equal to NBA. NBA is constant. I only have to differentiate cos omega t, and differential value of cos omega t is minus sin omega t into omega. So I will write it here. I do E is equal to first I will write d phi by dt, which is NBA into d by dt of cos omega t. NBA into d by dt of cos omega t. Here only cos omega t is varying. NBA is constant. That is why I took it outside the integral, outside the differential. Now d phi by dt is equal to NBA, derivative of cos omega t is minus sin omega t into omega minus sin omega t into omega. So I will get d phi by dt as NBA omega into minus sin omega t. This is the equation. This is the equation which has written here. Okay. Now E is equal to induced EMF E is equal to minus of d phi by dt. Then what will happen? This minus sign will go and you will get the answer as E is equal to NBA omega sin omega t. Now NBA omega is written as E0, that means maximum EMF. E0 is maximum EMF. Then I0 is maximum current. You can think like that. So E0 is written as NBA omega. So instead of NBA omega, I put E0 and my equation will be E is equal to E0 sin omega t. So what does that expression says? What does that expression says? It tells that the EMF varies as a function of sign. You have already learned how will be the graph of the sine wave. It will be like this. So from the equation it is clear that the voltage, the EMF varies sinusoidally. That means varies as according to the sine curve. So this is the graph for alternating current. Okay, with this chapter comes to an end. Thank you.